Welcome to MzansiNumerics. Today we are dealing with electric circuits that have an unknown resistor. So let's see how we can solve this. So let's go to equation 4. So on the right here we see already it is the formula sheet. So let's go through the information. The battery with internal resistance of 1 ohm and unknown EMF. So 1 ohm and the EMF is unknown. And then you see that as shown below, a high resistance voltmeter is connected across the battery, and then A1 and A2 represent ammeters with a negligible resistance, and switch S is closed, and the current passing through the 8 ohm resistor is what is 0.5. So let's just fill in 0.5 there before we continue. This is the current we are told what it's 0.5 amperes. 0.5, that's what we are told. Let me increase the size now. Okay, I think now it's enough. Okay, they say that state Ohm's law in words, and then Ohm's law states that the potential difference across a conductor is directly proportional to the current in the conductor and at constant temperature. So it is just this formula here, which is V equals to IR, to say that if I increases, this one will also increase. If I decreases, this one will also decrease. Why are we not talking about resistor? Is that resistor of a resistance of a resistor remains constant. So that's why we are talking about if this one, the potential difference across a conductor is directly proportional to the current passing through the conductor, provided the temperature remains constant. So that's how we define Ohm's law. Then see that calculate the reading of ammeter A1. So they want the reading of this ammeter A1 before the current is divided to the 8 ohm resistor and the 16 ohm resistor. What are we told? We are told this one, which is the current passing through the 8 ohm resistor. Let's see if we can find it. So what we have to know, let me just draw out this branch so that we can see how the current is moving there. So let me just name this A4, and then here it will be what, A5, and then there's gonna be the 8 ohm resistor there, 8 ohm, and then here there's gonna be the 16 ohm resistor. So this is how maybe it is. And then this is 0.5 amperes. So we are looking for the current here. So what we can find this current by checking that if we use this formula, R equals to V over I. So if something is beneath there, we can see already this one, resistance and current, they are inversely proportional to one another. If a resistor has high resistance, it means less current is gonna pass through it. It's gonna be harder for current to pass through in that resistor. So similar to here, because this one is 2 times here this resistance, it means that here current, it will be hard for current to pass through here, but it will be easier for current to pass through here, which means that here in A8, twice the current will pass through 8, and then here we see already half the current will pass through here, because we see that R is inversely proportional to what, to the current in this equation, and also according to the definition. So it means that if area is 0.5, we have to just find half of 0.5, and then it's 0.25, and then it will be the current passing through here, which is 0, what, which is 0.25, and then it's gonna, if we see, or for the current to come and be divided here, it has to be divided into these branches. Another one goes here, another one goes here. It means that if we add these two, we'll find the reading here. It will be 0.25 plus 0.5, and then we get 0.75. 0.75, 0.75. So now let's use the equation to see if we'll get the same answer. Let me just write here that 0.75 amperes, no, 0.75 is not here. Here we got 0.25 amperes, and then here when we add it we got 0.75 amperes. And then let's just use the equations now. So now here is the information that we were told. We were told this information that there's in the 8 ohm resistor we see this current passing through, so we can find the voltage of here, because we have been given the the current passing through that resistor, and we know that this resistor. So the current passing through the 8 ohm resistor is what? Is 0.5. And then what is the resistor? The resistor is 8 ohms. And then we come and do, and then we say this times this one. Let me press. And then we got 4 volts to say that the voltmeter reading across this is 4 volts. What is the position of the 16 ohm resistor in regards to this one? We see over there in parallel. And what do we know about voltage in parallel? The potential difference is the same. The voltage across the parallel is the same. It means that the voltage here is equals to the voltage here. So what does it mean? It means that here, if there was a voltmeter reading, it will also read what? It will also read let me make a small stroke so that it will also read 4 volts. If it was here, it will also read 4 volts. So that's why we are allowed to use according to this 16 ohm resistor. What do we know about it? We know its resistance, and then we know what? We know the voltage across it. It means that we can just come and substitute the 4 voltage across this resistor. We want to find the current across what? This resistor, and add it to the to this current, and we'll get this one. So the current, what is the current across the 4 ohm resistor? We are solving for it. And then what is its resistor? Is the 16. And then when we solve, we just divide both sides by 16, divide both sides by 16, and then the current passing through it, it will be, let me just make a little space. Then the current passing through it is gonna be what? It's gonna be 0.25. It's like this one, the one that we got by having this one. So but this the method that we used there was the first method. So preferably you must use this one with the formula. And then we write this is 0.25 amperes. And then how do we get A1? A1 equals to I of 8 ohms plus I of what? 16 ohms. We get for I of 8 ohms, or current of the 8 ohm resistor is what? 0.5 plus the current of the 16 ohms is what? 0.25. And then we get how much? We get 0.75 amperes, which is the current that we got here. So yeah, 0.75. Now let's go to the second one. Here the answer we got 0.75 amperes. So let me just clear my space so that we can work. Okay, so now it says that if device R delivers a power of 12 watts, calculate the ammeter reading at A2. So they are saying that if device R, so we are given the power of this one, to say that the power is 12 watts, calculate the ammeter reading here at A2. So we are given power, we are looking for current. So we must check which formula do we have to use for power. Here there is power, and then we are looking for current. So it means we can use power equals to VI. So it means we have to check that here's the current, and then this is the power that we are given. What else are we left to get the current? is we are left with the voltage. So where can we get the voltage of this resistor? We have to first know this resistor in regards to everything in this branch. They are in parallel to one another, to say that always the voltage across a parallel branch to one another is always the same. The voltage across the parallel to one another. So if we were to take a voltmeter reading, let me just do this, and we have this voltmeter here, and then we put it here, and then we take another voltmeter reading here, and then we do it like this, then we put it here. So this V3 and V2 will always be equal. V2 and V3 will always be equal, because what? Because we get that the voltmeter across the parallel branches is always the same. So we can just use this resistor and the information that we know here to get the voltage, and this voltage will be the same as this one here, and then we just come and substitute the voltage here. We have power, and just get the current reading of what? Of A2. So now how do we get the voltage? We must know that the voltage across this parallel combination, we have gotten it from the previous one. It was 4 volts. The voltage was 4 volts. And then what is the voltage across this one? And then we add it to this one, and then we'll get the total voltage of this branch. So let's see if we can find this voltage. So do we know the reading of A1? A1, we calculated it. It was 0.75 amperes. We got 0.75. Now we can get the reading here. So V equals to IR, and I here we got to because this one is connected in series, is gonna get all this current in A1. So the current in A1 is gonna be like this and passes through here before it's divided. So this 120 ohm resistor is gonna get the total current of 0.75 with it not being divided. So it's gonna get 0.75, and then its resistance is what? Is 20. And then let me calculate. And then its resistor is 15 volts. So now let's we got to here it's 15 volts, and then the resistor across the parallel combination is the same here because they are parallel in regards to one another. So this one's we had gotten where it's 4 volts, so it's gonna be 15 plus 4, and 15 plus 4 is gonna be 19 plus 4 is gonna be 19 volts. And then we just come and substitute the total voltage here will be 19, and then here is gonna be what? 19. So it's gonna be the same total voltage here across this branch because they're in parallel in regards to one another. So we come and put the 12 volts that we have been given of across R, and then here in this one we come and write 19, and then in the current we do this, divide both side by 19, and then the current we get we get 0.63. So that's how we get the current here, 0.63 amperes. That's how we got it here. Okay, so now let's go to the following one, which is calculate the reading on voltmeter when switch S is open. So let me just rub here. Okay, so now switch S is open. When switch S is open, because there's no current flowing, we say the reading on the voltmeter will be calculating the what, the EMF of the battery. It will be calculating the EMF of the battery. So now let's get the formula for calculating the EMF of the battery. If there's a current moving, this voltage will calculate the what? It calculates the external voltage. But if there is no current moving, it calculates the EMF. If there is current moving, there will be V external plus V internal. So now, because current is not moving, it will be both of them. So now let's calculate it. When we calculate it, we know that this one is equals to IR. This one is equals to IR, which is I of the small letter, R of internal resistance. That's why some they take out the common factor, and then that's how we get it here. So now let's just write it like this. So now we know the external voltage. What is the external voltage? We get what the external voltage, we calculated it across this branch is 19, across this branch is 19, which is the voltage of this circuit. And then here we just write 19, and then now plus what? Plus the current here. So do we know the current of this whole circuit? The current passing through here. We can get the current of the whole circuit. How can we get it? Because we know that here we had gotten 0.63 amperes, and then here you had gotten 0.75 amperes. So we know that before it was divided here, it was the total current. Before it was divided here, it was the total current. So we must just add these two, 0.75 plus 0.63, and then we just come and say we multiply by what? We multiply this, the current, we multiply by the internal resistance, which is 1, and then we get our EMF. What is our EMF? 20.38 volts. Yeah, that's what we get. So we are done with these questions. So because this video has been a little long, I will do this one, which is following in the next video. See you later. Be sure to subscribe and like for more videos. Thank you.